Hello and welcome to our lesson 5 on factoring quadratics, where we're going to put everything we've learned about how to factor quadratics together and try practicing a variety of quadratic factoring today. So our learning goal is to focus on factoring quadratic expressions in one variable using factoring strategies and to explore some special cases. So you will see some multivariable factoring as well, but I'll give you some time to practice those today, um, just so you get a little bit more familiar. So we have a flowchart here because we have now learned how to factor quadratics in different ways, but we're not necessarily sure how to choose when to use them. So looking at our flowchart here, when you're given any expression or equation to factor, you first want to see if there's a greatest common factor. As I said last class, we always want to work with smaller numbers. So if you can factor out a greatest common factor, do that right away. So if we go on the yes side, we are factoring out, or if there's no greatest common factor, we then consider now what type of polynomial do we have? Is it a binomial? So is it two terms? Does it have three terms? Or does it have four or more terms? And these are the three main polynomials that we're going to look at through this course. Um, so if it is a binomial, we only had one special case, which was our difference of squares. And for that, we want to check if the coefficient of x squared is a perfect square, as well if our constant is a perfect square. So if we have a squared and that b squared in there. And if we do, we have a formula there for factoring difference of squares, which is ax minus b and ax plus b. Now, if it is not a binomial, we will check if it's a trinomial. If it is a trinomial, we have now one special case here, which is our perfect square. For that, we are still checking for that a squared and b squared, but now we have a term in there with the x variable. And we want to check if that middle term fits our requirement of 2ab. So if we find the square root of a squared and b squared, is our middle term double the product of a and b? And if it is, then we have a perfect square, so we can write it as ax plus b squared. But if not, we are going to apply factoring by decomposition. And our new concept today, which we are looking at, is the polynomials with four or more terms. And how we do that is by grouping. So we're going to see some examples of that later in the lesson today. So let's look at our first example, and it is factor x squared minus 3x minus 18. So already, because x squared has a coefficient of 1, there's no greatest common factor, because I can't factor out 1, anything other than 1. So according to the flowchart, because this is a trinomial, I will check if it's a perfect square. Is 18 a perfect square? No. So it's not a perfect square, so I have to factor by decomposition. So factor by decomposition. And this is the case where a equals 1. So we want to find integers r and s so that the product is negative 18 and their sum is negative 3. And if you remember, this is c and this is b. So you can do trial and error. And honestly, for this question, I think trial and error works a little better than the strategy we saw in lesson 3 with the different way to find the factoring for quadratics, simply because you will be working with fractions if you try that method. If you are curious to try it, definitely go for it and see if you get the same answer. But if we do a little bit of trial and error, we see that 3 and 6 work to give us that 18 product, but it's negative 18. So either we have to have negative 3 times 6 or 3 times negative 6. So that's now where I consider my sum, which is negative 3. Between these two, the one that gives me fits both of these equations is negative 6 plus 3, or negative 6 times 3 to give us negative 18. So you can double check that. And now, if we factor by decomposition, we are breaking apart that 3 into negative 6x and 3x, which is what we have done here. And now, if we factor by grouping, we see that in the first two terms, they only have an x in common, and in the second two terms, they have a 3 in common. So you will get x plus 3 and x minus 6, or this one is also, either way works. And now we're done. We have factored. Our second example now is 3x squared plus 14x plus 8. Again, we want to look at that flowchart. First, is there any greatest common factor here? 3, 14, and 8. There's no greatest common factor, so I can't do anything. Now, this is a type of polynomial, which is a trinomial because it has 3 terms. So the flowchart tells me to check, is it a perfect square? 3 is not a perfect square and 8 is not a perfect square. So this is not a case of a perfect square trinomial. So we have to, again, according to the flowchart, factor by decomposition. And this is the case where a is no longer equal to 1. Here, a is equal to 3. Um, so factoring by decomposition now, we want to find integers r and s so that their product is 24 and their sum is 14. So through trial and error, we're going to find that here we have 3 times 8 is 24. Oh, so the two numbers that fit this description are going to be 12 and 2. So 12 times 2 is 24, and 12 plus 2 is 14. So factoring by decomposition, we're going to take that 14x term and write it as the 12 and the 2. So we have 12x plus the x. Now, if we factor by grouping, you will see that you get 3x plus 2 and x plus 4. So take a moment and pause and check that you get the same answer. And that is our second case for decomposition. And I've included a little definition here for you, even though we've been looking at this, but just a definition to really solidify the case of quadratics where a is not equal to 1. So if we have that kind of expression, our factors are going to be of the form px plus r and qx plus s. So x might have a coefficient, which is what we saw here with 3x plus 2. The x term has a coefficient of 3. It's not the case for both of them, not necessarily. We could have a coefficient for both brackets, but here we see that the second factor is x plus 4, so x has a coefficient of 1. So continuing, we still want that requirement for decomposition. So here PQ has to be equal to A because if we practice expanding, the first terms using FOIL will give us that PQX squared. So PQ has to be equal to A. And our last two terms, R times S, still has to be equal to C. And then we get from the inside and the outer terms, we get that PB plus RQ, which has to be equal to B. So same thing, just now we have coefficients for x. Moving on to our next example, factor 4x squared plus 32. So according to the flowchart, we first have to factor out the greatest common factor because here 4 and 32 are both divisible by 4, so we can actually factor that out. So then we have 4x squared plus 8. This is now a binomial because x squared plus 8 is only 2 terms. According to our flowchart, for binomials, we are checking if it is a difference of squares. So already here, x squared plus 8. I don't even have to check for the perfect for 1 and 8, simply because this is not a subtraction. It's not a difference. It's an addition. So that's it. You would be done here. There's nothing else we can do. The next example, factor 27 x squared minus 75. Again, according to the flowchart, we first have to factor out the greatest common factor because they have a common factor. And here, the common factor is 3, which gives us 9x squared minus 25. So similar to the example above, this is a binomial. So we check for difference of squares. And it is actually a difference here because it's a subtraction. So it could work. So let's see. 9x squared. Here, a squared being equal to 9 will give me a equals 3 or 3. So it is a perfect square. That works. Now, 20, we also need c squared to equal 25. And c would be 5. So that also works. So we could do the difference of squares. And if you follow the formula for that, you will get that this equals to 3x minus 5, 3x plus 5. And that would be our factored form for this equation, or this expression. Now, our next expression, factor 16x squared plus 64x plus 64. So already, the fact that these are even numbers, I know I have a greatest common factor. So check if your grade, but we want a greatest common factor. So here, there is a number greater than 2 that would divide all of these 3 terms. So take a moment to think about what that number could be, because first we have to factor out greatest common factor. So you should have gotten that the greatest common factor is actually 16. And if you factor that out, we get x squared plus 4x plus 4. Now, this is a trinomial, and our flowchart tells us, let's check, when we have a trinomial, is it a perfect square? So let's go back and check. So x squared will always be a perfect square because 1, or if a squared is 1, a is 1. So it has a perfect, it's a perfect square and has a square root. Our c term now, or c squared is 4, c can also be 2. So that's a perfect square. So now, for the perfect square trinomial, we have one more requirement, which is that a times c, or 2ac, is equal to b. And you will check 2 times 1 times 2 is equal to 4, which is b. So this is actually a perfect square trinomial, and we can factor it out as x plus 2 squared. So your final answer will be 16 times x plus 2 squared. Now we have our next example, and I hope you've noticed this one now looks different because it has 4 terms. So now we're getting that last example in our flowchart. So we have 4 more terms, so we have to factor by grouping. So essentially, we want to rearrange our terms so that terms that have common factors can be factored out. In this one, it's a little bit easier because it's already ordered based on their degrees. And if you try to group these based on 2's and 2's, you'll see they have a common factor. So let's look at the first 2 terms. X cubed minus 3x squared. They both have an x squared in common. And if we factor out, we get x minus 3. Looking at the next 2 terms, I see they also have a 4 in common. And if I factor out, I get x minus 3. But you're not done yet. Because These two both have that x minus 3 in common. So let's factor out the x minus 3. And we get x squared plus 4 because oh, that's coming from this x squared and this plus 4. And so now we were actually able to factor a polynomial with 4 terms into its factors. Now, take a bit of time, try this one on your own, and then I'll do one last example with you for today. So in this example, we have two variables. We have x and y. So we want to make sure when we're factoring out common factors, we are looking at both variables and the coefficients. So looking at the first two terms, we want to first consider the coefficients, -15 and -30. They are both divisible by -15, so I can factor that out. Now we will look at the x terms. They both have one x that we can factor out. And looking at the y terms, y and y squared, we also can factor out one y from them. So the first term, we just have x left, and the second term, we only have plus 2y. Now, the next two terms, we see if they have anything common. So again, the coefficients, we can factor out 5, and we can also factor out a y here. They don't have an x because the second term doesn't have any x, so I can't factor out x. And then we are left with x plus 2y. And again, here we're going to check because x plus 2y and x plus 2y. So let's factor out that x plus 2y, and we're left with -15xy plus 5y. And again, that's our factored form. We were able to factor 4 terms into 2 brackets. And our last example for today is, again, similar to above. So again, try it on your own. But if we try to factor this, the first two terms, we can factor out a 2y, and we're left with x squared minus 16. And from the second two terms, we can also factor out 3. 3y squared. And we get x squared minus 16. And so now we have this in common. So we factor out x squared minus 16 and 2y plus 3y squared. And so this one has, and we might even go back to the last example because I see something in there we can factor out too. But we want to be also checking, even at this step, can I factor any more? And if we look, we actually can. So let's look at this bracket first. X squared minus 16. I hope you can recognize that as your difference of squares. And this one is actually now x plus 4, x minus 4. And if you look at the next bracket, you'll see that they both have a y in common. So if I factor out that y, I have this. And just for correct mathematical notation, we always want to move all our coefficients and our solo variables to the beginning. So y there, and then x plus 4, x minus 4, and 2 plus 3y. And now we are done. If you try to check any of these brackets, you'll see that we cannot factor out anymore. So that would be our final answer. So now, look at this question one more time at the top. Is there anything else we can factor here? So you should see that the second bracket has a common factor, and it would be 5y. And if we factor out, we get -3x plus 1. And that first bracket, I'm just going to leave it as it was. X plus 2y, x plus 2y. I can't factor that one out anymore. And so that would be our final answer. So you're not going to see a lot of the polynomials with four terms in our course, mostly just for this lesson is practice. Um, so definitely try, especially when we get to that ending point where we want to check if we can factor out any more with our brackets. I know it's a little bit tedious to do all of those steps, but then you get the most simplified answer. So if you are later working with that expression to solve like word problems, it makes your life a lot easier. So that was our lesson today, and I'll just go over the practice questions with you. So we have some factoring. These ones, it suggests to you you may need to uh, factor out a greatest common factor first, so definitely check for that. We have some word problems and more factoring. Um, so with factoring, it's just something that you have to practice a lot of, see a lot of variations of it, see all the different types, so your eyes kind of get familiar and you can recognize them. For example, here in this question, once I saw that x squared minus 16, I already knew because it's something I had seen before. So I hope that through practice, you're also able to recognize these common polynomials and how we can factor them, and also to be more comfortable with their factored form, so you're not going through the steps as much and it kind of becomes a little bit more automated. And that is our lesson today. I'll see you next class.